Question 11. Show that sine 2x over 2 cos x minus sine x cos squared x equals sine cubed x, where x is between 0 and pi over 2. Okay, so straight off you should be thinking trig identities. So it's quite a simple one actually. So the difficult part here is this 2 sine 2x. So we'll go up to our formula sheet, and which one? There's only one available, so we'll substitute in this for this value here. So this just then becomes 2 sine x cos x over 2 cos x minus sine x cos squared x. I'm saying this is equal to sine cubed x. So back to the question. Okay. So already we can simplify this. We can simplify the 2 and the 2 and the cos x and the cos x. So this then becomes sine x minus sine x cos squared x equal to sine x cubed. So there's a common factor here of sine x, so we can take that out. So sine x, that just is 1 minus cos squared x. You might recognize where I'm going with this, but I'll just keep going. Sine cubed. Okay, so we should know that the relationship of sine squared x plus cos squared x is equal to 1. So that's the same as saying sine squared x is equal to 1 minus cos x or squared x. Now you should see here that this is exactly the same as this. So we can just substitute that in, and this then becomes sine x times sine squared x equal to sine cubed x. So sine cubed x is equal to sine cubed x. Right, that's it there. So that's your final answer. You could write as proven. So where are the marks in this? Well, you get 1 mark for substituting in for sine 2x here, and you get another mark for simplifying and factorizing here, and you get a your final mark here for substituting in this expression and getting the proving the statement basically. Okay, part B. Part B is not even too bad either. So part B. Hence differentiate sine 2x over 2 cos x minus sine. So that sounds, oh, how am I going to differentiate this? Well, from the previous question, we know that, well, we could write it all out. So sine 2x over 2 cos x minus sine x cos squared x. Well, we know that that is equal to sine cubed x. So from A. So now it's just a case of differentiating this statement here, which is quite a bit easier. So this then becomes, so we'll call this f of x. So f dash x, then this is just chain rule, equals 3, and then this isn't going to change in here, sine and the power is going to go down. Sine x, sine x squared, decreasing the power, then you multiply by the derivative of what's inside the bracket, so cos x. So this then just becomes 3 sine squared x cos x. That's pretty straightforward. Okay, so you get your marks for this question. Well, you know, you get your mark basically for knowing to differentiate this term and not the other term, and you get your second mark for starting the differentiation. Then you said you get the second mark for completing the differentiation, so that must be this here. So that's 3.